Welcome back to the Game Blocks tutorials. This tutorial covers platformer gameplay, mostly focused on movement. Most of the interactions that you'll want to create with colliding with things, deducting hit points, animations, most of that can be covered with the general tools shown in some of the other tutorials, such as the cartoon blocks. This will concentrate on the complexity of integrating a jump that involves some physics with the movement code for moving across a sprite surface. So that takes a little bit of setup. We're starting with the place we left off from in the movement tutorial. So if this is something you're coming to fresh, watch the movement tutorial and you'll end up right here where we have a collision sprite defined and we kick off a command to handle movement of this player character here. So we're going to start with that. We're going to break this off from the start of the game actually, because what we're going to do is initialize the physics system here, and that will take a few seconds depending on the speed of your computer. These blocks take a while to load themselves and configure themselves. I'm still surprised at how slow they are, but that's a fact of life we have to deal with. So what we're going to do is initialize the physics system. Now if you're going to do a platformer game, you'll want to watch the videos on the physics system itself as well as the movement tutorial to get an understanding of both, to understand how they work together. There's a little bit of setup for these blocks. So for the physics system we need a couple of variables, a few variables actually. One is going to be the physics loop itself. So we'll just call it player physics loop. I think that will make sense. Yeah. Okay. We end up having to hold a pointer to the physics system. So we're going to make another one, and we're going to actually grab references to some routines within the physics engine. This is all extra overhead needed just for the sake of performance. So this stuff has gotten a little more complicated than it needs to be, mainly to work around some performance issues inside the block system. So let's see, we'll call this jump proc. Just keep it short. A procedure for jumping quickly, and we'll make a variable for stopping the physics engine. Okay, so we're going to initialize these variables over here. Formally speaking, we probably wanted to do local variables on maybe a couple of these. Well, no, maybe not. Maybe not. We want the platform to be able to stop the physics engine as well. Let's see. What I'm going to do. Can I change this name? Too late now. You'll see in this sample that I keep the player name in both of these in the sample in the BYOB, sorry, in the game blocks examples folder, because this is really a procedure specific to the player's physics loop. So really it should be called player jump proc, player stop proc, but we'll keep moving. Okay, so to set these, we grab a set command here, and let's just go ahead and start with the physics loop for player. Physics is all stored in the motion block. There's a ton of physics blocks. It's a lot to sift through, but what we're going to do now is just grab the initialization block. So here it is. Make a physics loop. So it's a round block, so it returns a value basically. It just takes all the code of a physics loop and starts it running and kind of returns a pointer to that object, so that we then can store it here and lets us access it quickly. So we've got that, and we're going to set a couple more. Now that we have the physics loop, we can grab these procedures out of it. Let's go ahead and grab both of these commands while we're here for the sake of efficiency. Jump proc and stop proc. And what we do is use a special physics command. Typically, we get a physics loop, we can interact with that loop specifically by using these commands, and you notice they all have, physics mass of blank. Set the center of blank. That blank is filled in by this physics loop variable. So you're always talking to a specific physics engine running on a specific sprite. Okay, with that in mind, we want to get a routine. It's this one here, get from blank a fast command for blank. So again, not the most intuitive system, but all this kind of fell out of needs to make things fast. So let's see, get from player physics loop fast command for jump. And we'll do another one of these. Let's just duplicate what we've got. And the other command is stop. So for most games, you'll probably be fine just to follow along with this tutorial, copy what we've got here. If you really want to delve into the physics engine and learn what all the commands are, so you can get fast versions of them and access them, there is a documentation file included with the toolkit. So you can look through that. It defines what all these are and then what the arguments are to pass in. So check that out. Alright, so we've got the jump proc and the stop proc. We have set up a collision sprite. Let's go ahead and just let this be part of our general initialization. We could do some things like setting the player start position and stuff, but we'll skip that for now. And what we want to do, once all this is completed, this will take 5 seconds or so. We will send a message to the rest of our code to let it know it's time to initialize and get running. So we'll just broadcast an event. We'll make a new one. And strictly speaking, it should be player physics initialized. When I've experimented with physics on multiple sprites, I've kind of chained them. I've had the physics for one initialized, then another one, and just kind of used messages to pass it through. I don't know if that's the most efficient. It let me make sure I knew everything was initialized before I started doing anything. So I grabbed when I receive and attach it to this movement sprite. When I receive player physics initialized, and this should be enough to get us going on movement. Now another thing we want to do is, with the platformer game, we're going to have two states for this player. He can be walking on the ground, or he can be jumping. So we want to record that in a variable and use that to switch the movement state, or the movement code on and off, and switch the physics code on and off. So we'll create a new variable. Movement state. Alright, well, we'll need to initialize that as well. Collision sprite, we'll set movement state. We'll start out walking. Okay. So now what we'll do is make this block more complicated. So in the movement test, movement tutorial, we just had it running all the time by passing in the true value. We're just going to take this out and do something related to the state of the player. So we're going to check if the movement state is equal to walking. So again, make sure the gray bar is around that to make sure it's not being evaluated immediately. And we'll grab the movement state variable, plop it in there, and just type in the word walking. It's our state. As long as we're walking, movement will be happening for the player along the ground sprite, or along the ground, which is the collision sprite. Okay, so good enough, but let's at least put a basic jump in to see that working before we won't get too fancy with that right away, but just see that working. So same thing, when we receive player physics initialize, we'll start the jump code. We'll just put that here. And what we're going to do is just create a condition. This will be looping forever, checking to see if the player is walking, currently in the walking state, and pressing the space bar. So we can do that with a forever if. and we will use an AND to check those two conditions. So we want to know if we are walking and the player is pressing the spacebar. So first thing would be checking the player state. Oh, I could have just grabbed the whole thing from here, but we'll do it the long way. Now if I mistype walking, everything is broken, but looks good. Alright, so if the player's walking and the key is pressed, the space bar is pressed, then we're going to jump. Now we'll do the simple thing now. We want to get some more to this, but for now a simple jump command would be we need to call this procedure, this jump proc, and pass it some values. So we need to go get a special command to call that. So again, we've kind of reached into the physics engine and grabbed a piece of it so we can call it quickly. You know, if you don't do this, it's like a 2-second delay. It's really kind of mystifying, but this kind of avoids that problem. So let me see if I can find my call. There it is. This is a custom command. With BYOB there is a call function, and right here, the round one, it returns a value. It's really intended for calling a procedure and getting its return value. I created this so we can just use it as a command. It makes the syntax quite a bit simpler. It actually ignores the return value, which is a bit sloppy, but still it makes this process a little bit easier to set up. So we're going to call the jump proc. So it will be stored in this variable by this point. And it takes some values. Again, this is where you would check the documentation if you want to make use of these commands in this way. I'm just going to throw some values in. It's basically a magnitude. Oh gosh, if I can even remember. It's a magnitude of the jump. So let's say we're going to jump at 10 velocity and a direction. So we'll jump at 0 degrees. So in BYOB, 0 degrees is straight up. 90 degrees is straight to the right, and it kind of goes around clockwise like that. So we're going to jump straight up at 10, and we're going to have a force of gravity pointing down of 0.8, and pointing down would then be 180. Okay, so that'll jump us up, turn on gravity pointing down. Now we haven't done something we need to do. Immediately when we decide we're jumping, we need to turn off the movement block here. So we want to change movement state to jumping. So let's go ahead and do that with a set movement state jumping. Alright, there we go. See if this works. That's a lot of code to just trust to work. Alright, we're moving back and forth. And if I hit spacebar, it doesn't work. Okay, I figured it out. Once again, not using cut and paste is proving to be a bad idea. So I misspelled walking, and that is probably the problem. So let's give it a shot. Alright, there we go. And he falls and dies because we haven't hooked up the rest of the machinery. But that's the basics. So we've gotten the movement working and we've switched to the physics system. Now what we have to do is switch back to the movement system once we land back on the ground. So first thing I'm going to do is just a little bit of housekeeping. This always makes me a little bit nervous to do this kind of thing, but since we're moving along here, you never really know if like one pixel is going to be touching another pixel. So let's just make sure we're not touching the ground when we start our jump. And so the way I have done that, and this is just inviting an infinite loop, but it seems to work pretty well. I do a repeat until we're not touching the ground, this kind of upward movement. So repeat until not touching the ground. Where is it? Touching collision sprite. just move up 1 in Y. So we'll just, before we kick off that jump, let's just make sure we're really not touching the ground so we don't confuse the physics engine. Now what happens is the physics engine, well, hold on. Okay, no, that's the next thing I want to talk about. So really it's up to us to decide when we've touched the ground. Only our game knows if this is a platform or if that's just a cloud in the background or whatnot. So it's up to us to decide when the player has touched ground again. And so what we're going to do, we're just going to put it on the ground itself right now, but we'll do a condition to check for the player colliding with the ground. And then we will turn off physics and turn movement back on. So that involves a couple of steps. So strictly speaking, we probably shouldn't turn this on until the physics engine is initialized, but I don't think it's going to cause much harm to do it this way for now. So let's see, or should we be correct about it? Let's be correct about it. Alright. We'll say when we receive player physics initialized, we'll start looping forever, checking for that condition. So we're checking to see if anybody's colliding with us. Or no, we're checking to see if the player is colliding with us. So a touching condition, pull down, select the player sprite. So if the player collides with us, we first want to check if the player, we know the player's colliding with us, we want to check to make sure we're not walking. If we're already walking, then we'll let the movement engine continue. But if we're not walking, then we have work to do. So we have to put another if inside of that. Okay, if we're not walking, so not state equal walking. See if I can spell walking correctly this time. Okay, if not state equals walking, then we're basically going to set up the movement system just like we did before. So we'll set the collision sprite to us. If I wanted to be fancy, I could check our attribute and get our name from there, but let's just type it in here. It's probably the simpler way. So set collision sprite to the name of us. We're going to change the movement state back. So we are going to be walking now. And we're going to stop the physics engine. We're going to do that by using that fast proc we created. So digging down, finding that call block, grabbing the jump procedure, call jump procedure. It doesn't take any arguments, so we can delete that arrow. And this is just something I've discovered. It's just generally safe to wait a split second just to let this switch over happen before letting this loop continue. So I'll do a little wait. All these scripts run in parallel, and it's really cool that they do that, but it also opens up many possibilities for race situations. So let's do just 0.3 I found works good. You can probably do a less than that. Alright, so that should get the jumping working for the ground. But you know what? We need to put this player somewhere else. Put him up here. See if this is actually working. It is working. Okay. Jump. Alright, so we're jumping. It realizes we've collided with the ground, switches the movement system back on. And it's really as simple as setting this movement state here. By setting this variable here, we're basically communicating with the movement system because we've passed in that condition to the movement system via the block. So you can see right there, when we pass that condition into the movement block, it'll always be checking the movement state variable. So now it's like a register. We've got a little state machine we're working with. We just change the state of that variable, and the movement system changes what it's doing. Okay, so let's go ahead and make this platform work. It's the same script as we just used on the ground. So we'll just copy that script over to the platform. This loading does take a while, doesn't it? This is actually a pretty fast computer too. I'm not quite sure why. Okay. Here we go. We should have a nice big script on the platform now. And we'll change the name of the collision sprite to platform. So now that will tell the movement system not only to start working again, but also that now it's watching out for the platform. Now, you know, this is not the most ideal collision. You might want to have a top of a platform and a bottom of a platform. So if a player collides with the bottom of the platform, you do something different, like just turn gravity back on and let the player fall. But this, you know, for simplicity's sake, we just collide with the platform and turn stuff back on. This will make sure the player moves up on top of the platform as soon as you collide with it. Alright, so let's see. We may not be able to jump to the platform because we haven't set up. Oh, I guess we could do it this way. There we go. Now we're up on the platform. So notice we can't run and jump. When we run and jump, we jump straight up. So that's not ideal. Everything's working now. We've got, well, it should be falling here. Oh, I know why I'm not falling. Let's make ourselves fall, and then we'll do the complexity of doing a jump sideways. Alright, so to make ourselves fall, what we are getting actually is a message from the movement system that'll tell us that. So 2D movement is checking to see if you're on top of the sprite. Once you're not on top of the sprite anymore, it sends us a special message called player falling. So we need to catch that message and turn on gravity, basically. So we catch the message. This is kind of the opposite of what we just did to turn the movement system back on. We'll turn the movement system off, turn on gravity, and then we'll just start falling. So that's actually not so hard to do. Let's just add that script down here. Let's make the window bigger. No, it's going to make me leave it there. Alright, let's get started on. Oops, not that one. When I receive player falling, it's already set up. This message is actually created automatically by the game blocks when they're imported. So it's in all caps to indicate it's part of the core system. So it's already there for us. So I check if that we've received that event, and then we're going to set our movement state to jumping. We're jumping. We just didn't actually jump up. We're jumping down. And we're going to call the jump proc. And we'll just call it with no energy. So we'll just kind of turn on gravity is basically what we're going to do. Where's my call? Where's call? Probably grab this from somewhere else. Here we go. Let's just do it this way. Make it faster. So call jump proc. Got our 4 parameters. Again, these are documented in the documentation file in the toolkit. And we're going to jump with 0. Hello? We're going to jump with 0 speed, going down. This really kind of gets ignored because there's 0 speed. We're going down. We could provide an impulse there if we wanted to. We're going to keep the gravity the same, and gravity still pointing down 180 degrees. So that should turn on falling for us. Let's check it out. Oh man, we actually land on this platform, so we left ourselves there. The system realized that somehow, so get to the edge and we fall. There we go. We can jump up here, get to the edge, boom, we fall off. Okay, so it's that easy. Catching an event, changing the player state to switch off movement, and then kicking off the physics engine by passing in some values to it and making gravity work. Okay, so all of that is there. So the last thing's really, this is pretty much an advanced topic, but you really do want to be able to jump right and jump left. So let's go ahead and add a little bit of logic for that. And this is where the code starts to look complicated, but it's just kind of a elaboration on a theme, I guess. So instead of just doing the same thing every time jumping straight up, we need to check if the player is pressing right or pressing left. Your game may have a velocity or something it can check, but for this we'll just check if the player is actively pressing the right arrow or left arrow. We'll jump in a slightly different direction. So the way we do that, you've probably seen logic like this before. We'll just do an if-else statement. Kind of nest some if statements. Let's see, we're still going to do that repeat to get the player off the ground, to make sure they're off the ground. So the logic is basically we'll just start checking to see if keys are pressed, and if we don't find any keys pressed, eventually we'll default back to what we had here. So key pressed. Key, we're using arrows key still, so if the right arrow is pressed, we'll do basically, let's keep this in. We're going to put the movement state up here. And we're going to do that every time regardless, it's just the jump that's changing. So we'll duplicate this jump here. So we're going to have actually another if-else inside here. So basically if the right arrow is pressed, do something. We'll change those numbers in a second. If the left arrow is pressed, so if it's not pressed, check if the left arrow is pressed. If the left arrow is not pressed, then else do something else. That's how this ends up being nested like this. Left arrow, and then else. And now we're down to the state we covered, which is neither left nor right is pressed, so we'll just jump straight up and down. For these other two cases, we need to change the numbers slightly. And all we're going to do is change the direction we're jumping. So if the right arrow is pressed, we are going to be jumping 25 degrees. So that's, remember, up is 0, all the way to the right is 90, so 25 degrees is kind of like that. And if you're jumping left, we'll make that number of degrees 335, which is that. I'm copying this off of another script. Is that right? Yeah, I guess that's right. 360 minus 25, so 360 would be all the way back around, and we're just subtracting 25 this way. Okay, so I think now we have jumping sideways, which will make this a little bit better. Oops, I gotta wait till it starts. Alright, there we go. You can do that kind of thing, jump off. You can still jump straight up and down. So if you're pressing the arrow key and jump, it gives you some velocity. So there you go. So you have something that starts to feel like a platformer game. And I think that'll cover it. Like I said, watch the movement video. It's got some information on how to draw these sprites so that you have empty space for movement. And check out the physics tutorial as well. Enjoy.